Okay, so we are going to go over 5.6, ready, set, go, number 6. This one right here. And so this one says, students in a high school math class were given the following problem. I don't know why this is so tiny. It says, while traveling across a flat stretch of desert, this part here, right? Joey and Holly make note of the top of a butte in the distance that seems to be directly in front of them. They estimate the angle of elevation to the top is 5 degrees. So angle of elevation is the angle that when you are staring horizontally, like perfectly horizontally across, this side represented by this side here, and then you tilt your head up a tad to look at the top of something. So there's a thing, I think it's called a chronometer or something like that, that will measure that angle for you. So you can measure the top of a flagpole, and you can grab that angle of elevation. So the angle of elevation, think about this like when you're, this is the one example that I know that's really easy for everybody to think about. Like think about the last time you went to the movies, and let's say you sat in that very front row. Your angle of elevation is large. It's almost like 90 degrees, right? Because you have to sit like this the whole time. Like you're staring almost like up towards the ceiling. So you would stare all the way up here, right? Like whoosh, right? Versus if you sat like, like in the middle of the theater, then your angle of elevation is almost close to zero, right? Where you're almost staring straight ahead. Very comfortable, right? So your angle of elevation is the angle made with the horizontal towards up. There's an angle of elevation and an angle of depression. Depression, not sadness, but depression as in lower. So you could, like, let's say you were standing, like, I don't know, on the second floor of, a building, and you're on the balcony. Now you're looking out and down at the city below you. That would be called an angle of depression. Okay. So after traveling 6 miles towards the butte, here's your 6 miles. Boom. The angle of elevation is now 25 degrees. Boop, right? Approximate the height of the butte in miles and in feet. So they want to know D. So as long as you know that 5,280 feet is 1 mile, and then use the given values for X in miles, D in both miles and in feet, knowing that tangent of 5 is about 0.1 and tangent of 25 is about 0.5. By the way, buttes, not butts, buttes are tall, flat tops, steep-sided towers of rock. Okay, so there's a gigantic butte right here. Okay, we're figuring out how much that is. Okay, so with that being said, they just want us to find this. So there's a lot of information here. I usually like to ask you the question, how many triangles do you see? And you would say 3. I see this small right triangle. I see this, they call it oblique or obtuse triangle. Does everybody see that guy? And then I see the big, long right triangle. Okay. And so for me, the very first thing that I would want to do is I'd want to know, I would want to know as many equations as I can, because it looks like I'm supposed to find 2 things. I'm supposed to find X, which is this, and D, which is this. Okay, so the first thing that I'm going to do is I'm going to write out a couple of equations to help me solve this problem. So what are some equations that'll help me solve this problem? Yeah, the tangent's going to help me. So I'm going to write tangent of 25 degrees is equal to D over X. And that seems like a silly equation because I'm like, okay, well, that's not going to help me because I have 2 variables. Okay. And then, hold on, let me let this guy catch up. Okay. And then I say, okay, well, what about this 5 degrees? I can also use tangent of 5 degrees is equal to D over, and it's this whole thing from here all the way to here. So I would add these 2 together, right? Pretend that, that we were on this trip with them. We rode in the car for 6 miles. We stopped, we measured, and then we rode X more miles. So for a total of X plus 6. So these 2 equations together, whenever this guy decides to show up, is two equations with two unknowns, which is also known as a system of equations. So because of this, I'm going to reach back into my brain and be like, oh yeah, I could use substitution. I could use elimination. I could use one of those. So I'm first going to start with substitution, because substitution is my favorite way to solve systems of equations. There it is. Okay. So first, it seems as though that I could solve for D in both of these without like too much headache. So this one, I'm going to solve for D by multiplying by X. And so I get X tangent of 25 degrees equals to D. Now, instead of writing this D over here, I'm going to write what D actually equals to, what I got over here, right? Okay. Still not showing up. There it goes. So I'm going to copy this whole equation, but instead of writing this D, I'm going to pop this in here. So it's going to say tangent of 5 degrees equals to something over x plus 6, right? And then I'm going to take this whole thing and I literally am going to copy this because I can, right? So copy this, paste it. I'm going to put it over here because this is what I think my equation is going to end up. It's like super slow. I wonder if it's slow. I think I have an idea on how to make this faster. It's just sitting there. All right, I'll be right back. Okay, so the equation showed up, so there it is. And then, so just imagine that equal to pushed over a little bit. Now I want to solve for x, right? Now I want to solve for x. So what I do, let me scoot this over. So then what I'm going to do is I'm going to multiply. Well, I guess I can plug these in right now. I'm going to plug these in first because then that'll make you guys feel a little bit more comfortable. Tangent of 5 is 0.1. So this is now 0.1. X tan 25 is going to be 0.5x. So this is now approximately 0.5x divided by x plus 6. So I just plugged in my values for x, for tangent. And then so when I do that, okay, so then because I have x's, I want to have them on the top and the bottom. Notice your rational brain self, as in the chapter that we finished a little bit ago, would tell you that x can't be -6, right? So that just know that. But I don't think it's going to be -6 because then that would not represent a triangle. Okay, so I'm going to multiply both sides by x plus 6 because that's the least common denominator. So I'm going to multiply by x plus 6. That'll cancel with that. And then multiply by x plus 6 on this side, and then distribute, right? So then I'd have 0.1x plus 0.6 equals, is about 0.5x. And then I could just solve it. Okay, so then I would get the x's on one side. So that's 0.4x is about 0.6. And then I would just divide by 0.4, which I then think the answer is 1.5, right? I think x is 1.5. Can someone check that on my calculator, please? Yeah. Okay. So I filled in all my numbers over here. So I now know what x is. And now I'm going to find out what d is, right? So here's what d is, and then I just plug it in here, right? So I am going to plug in there by going like this. So d is equal to, I guess approximately now, 1.5 times tangent of 25 is saying it's 0.5, right? So whatever that is, half of 1.5 is going to be 0.75. So this is about 0.75 miles. Okay, so let me let this catch up. Okay, so here's our answer. So the last thing that we would have to do is it says they want us to write it in feet and miles. So the way I would do this is because I know there's 5,280 feet in a mile, I would just multiply each of these by 5,280. And then there's my answer. So let me show you that. So I would just go 1.5 times 5,280 feet. So that's going to be 7,920, and 0.75 times 5,280 is 3,960. So I will write those answers down. So what is this? 7,920 feet. And this is 3,960. There you go. Okay, so there's my answers for both X and D. And then that's all you'd have to know.